Trigonometry, Chapter 4, Graphs of the Circular Functions, Section 3, Graphs of the Tangent and Cotangent Functions, Video 2, Constructing the Graph of the Cotangent Function. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we constructed the graph of f of x equals tangent of x. The period was pi, the distance between consecutive pairs of consecutive asymptotes. Asymptotes were at odd multiples of pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2. X-intercepts are at multiples of pi, 0 pi, 1 pi, 2 pi. Branches are increasing between pairs of consecutive asymptotes. And the quarter period behavior over one cycle is vertical asymptote, -1, 0, 1 vertical asymptote. This particular cycle starts at negative pi over 2. In this video, we construct the graph of f of x equals cotangent of x using the graph of f of x equals tangent of x and the reciprocal identity cotangent x equals 1 over tangent x. We will not be making a trip around the unit circle this time. To get the graph of cotangent, we analyze what happens when we reciprocate the graph of tangent. Technically, you don't reciprocate a graph. You reciprocate the y-coordinates of each point on the graph, but we'll use the term loosely. We start with the quarter period points whose tangent are -1 or 1. These are at odd multiples of pi over 4 and alternate between -1 and 1. By odd multiples of pi over 4, I mean 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, etc. Because the reciprocal of 1 is 1 and the reciprocal of -1 is -1, these points remain as part of the graph of f of x equals cotangent of x. Next, consider the x-intercepts of f of x equals tangent of x, highlighted in yellow here. These occur at multiples of pi, 0 pi, 1 pi, 2 pi, etc. At the x-intercepts, tangent of x is equal to 0. Thus, cotangent of x equals 1 over tangent of x is undefined. This means that the x-intercepts of the graph of f of x equals tangent of x, the yellow dots, become vertical asymptotes of the graph of f of x equals cotangent of x. Let me point that out again. Where the graph of tangent crosses the x-axis, we get vertical asymptotes for the graph of cotangent. So the red ones are going to be our vertical asymptotes for the graph of cotangent. Next, consider the asymptotes of the graph of f of x equals tangent of x, highlighted in light blue. These occur at odd multiples of pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, etc. Just as the x-intercepts of tangent become the asymptotes for cotangent, it's going to work in reverse. The asymptotes for tangent, watch the asymptotes, they collapse into those yellow dots. Collapse into yellow dots. The asymptotes of tangent become the x-intercepts of cotangent. So in other words, the relationship between tangent and cotangent is the x-intercepts for one is the vertical asymptotes for the other. Now, let's remove the blue branches, the branches of the graph of tangent in purple, as well as the blue vertical asymptotes of tangent. So goodbye purple, goodbye blue, and now we're left with this. Dots on the graph of cotangent and the vertical asymptotes that separate the branches. I think you can see where this is going. Connect the dots and approach the asymptotes, and we look like this. Here's a cleaner version of the graph of f of x equals cotangent of x. Now, like tangent, cotangent has a period of pi. However, the branches of the graph of cotangent are decreasing between pairs of consecutive asymptotes, unlike tangent's increasing branches. This naturally follows from the nature of the quarter periods. So here's a summary of the graphs. We see both of them here, kind of smaller, but just for comparison purposes. They both have a period of pi. Asymptotes of tangent are at odd multiples of pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, etc. But asymptotes for cotangent are at multiples of pi, which you could think of as even multiples of pi over 2. 0 pi, 1 pi, 2 pi, or equivalently 0 pi over 2, 2 pi over 2, 4 pi over 2. And the reason I point them out as even multiples of pi over 2, it's because that contrasts odd multiples of pi over 2. Now remember that the x-intercepts and the asymptotes traded places. Where there was an asymptote for the graph of tangent, we had an x-intercept for the graph of cotangent. And where there was an x-intercept for the graph of tangent, we had an asymptote for cotangent. For tangent, the branches are increasing. For cotangent, the branches are decreasing. And although we haven't mentioned the quarter period behavior yet for cotangent, I'm going to fix something real quick. OCD's kicking in. Not sure if you caught what I changed, but back the video up and you'll see it. But here's a summary of the graphs. In the quarter period behavior for tangent was vertical asymptote, -101 vertical asymptote. Notice the increasing behavior of the values. That started at negative pi over 2. And the quarter period behavior for cotangent was vertical asymptote 1, 0, -1 vertical asymptote. That was starting at x equals 0. So the graphs have their similarities and differences. They're essentially the same shape. It's just that tangent is increasing, cotangent is decreasing, and they swap x-intercepts and vertical asymptotes. Now you try. Pause the video and try the following. Here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, and 1. Same periods. Asymptotes and intercepts switch places. Tangent branches are increasing. Cotangent branches are decreasing.